Okay, and here we go. We're working right now on day 3, practice 2. It has all the problems that are similar to the ones you'll see on the test, except for 3 problems, which we will be learning later. So here we go. We see an equation, and we're going to follow our rules, our DC-GAM of can we distribute? Nope, we can't. Can we combine like terms? Nope, there are none. X's on both sides, there aren't X's on both sides. So we can't do anything until we get down to step number 4. We couldn't do the first 3 steps. So step number 4 says add or subtract to get rid of terms on the side that X is on. Well, here's X all by itself. Well, it's by itself except for this 4 that's being added to it. This 4 is a positive number, so to get rid of the 4, we're going to subtract. And whatever we do to one side, we have to do the other. So 4 minus 4, gone, that's 0. It disappeared. We bring down the x, we bring down the equal. 18 minus 4 is 14, and we're done. This next one, there's nothing to distribute. But when we see step 2, combine like terms on the same side, if I cover up and just look at the left side of the equal sign, I see that 3x and negative 7x are like terms. We can combine them. So 3 minus 7 is negative 4. So 3x minus 7x is negative 4x. I bring down the equal. I bring down the negative 12. And now I look, I don't have, all right, I did this, so this is good. Get all the x's on the same side. Don't need to do that. Add or subtract to get rid of terms? Nope, don't need to do that. But this very last one, multiply or divide to get x all alone, that's what I need to do. This negative 4 is being multiplied by the x, so I'm going to do the opposite, and that is division. So negative 4 divided by negative 4, that is 1. And I could write 1x, but I'm just going to write x. And then negative 12 divided by negative 4 is 3. And that is my answer. Okay, this next one, we can't distribute, we can't combine like terms. There's only an x on one side of the equal sign, so we don't need to do that. But this one, add or subtract, I'm going to look at this negative 6 to get rid of it. I'm going to add a 6, but whatever I do to one side, I have to do the other. So I bring down the 5x. Negative 6 plus 6 is 0. I could write plus 0, but that wouldn't make sense. I'm just not going to write anything. So I'm going to bring down my equal sign. 14 plus 6 is 20. And I'm done with that step. Can I multiply or divide to get x all alone? Sure I can. 5 and x are being multiplied together right now. So to get rid of 5, I divide. But whatever I do on one side, I have to do the other. So then 5 divided by 5 is 1. So I could write 1x, but I just am writing x instead. 20 divided by 5 is 4. So x equals 4. For number 4, there's nothing to distribute. There's no combining like terms on the same side of the equal sign. There are not x's on both sides of the equal sign. Okay, here we go. Add or subtract to get rid of terms on the side that x is on. So the side that x is on, there is a 3. I'm going to get rid of it by subtracting. And so I end up with 1/4 x equals, 3 minus 3 is gone, 7.1 minus 3 is going to be 4.1. And so what's left? We already added or subtracted. We did that. And so we're going to either multiply or divide to get x all alone. The way that I think is the easiest to understand this is if we go ahead and just divide both sides. See how 1/4 is being multiplied by x? To get rid of it, we have to do the opposite, which is to divide. I know this looks funny, but our calculators can handle it. 1/4 divided by 1/4, that's 1. I could put 1x, but I'm just going to put an x because that's the same thing. And then I'm going to turn my calculator on, and I'm going to put 4.1 divided by, hit the fraction button. I'll put the 1 on top and the 4 on the bottom. Hit enter, and there we go, 16.4. Okay, this next one, yay, we can distribute. That's always the first thing we look for. Can we distribute? In this problem, we can't. 5 times 2x is 10x. 5 times 1 is 5. I bring down the equal sign. I bring down the 15. So I have distributed. Are there like terms on either side of this equation? No, so I can't do that step. Are the x's already on the same side? Yep, there's only one x, it's on the same side. All right, next step, add or subtract to get rid of terms on the side x is on. Well, x is on this side, the left side, so I'm going to get rid of the 5 first by subtracting it. Whenever I do to one side, I have to do the other. So then I bring down my 10x. I didn't do anything to that. 5 minus 5 is 0. I could write plus 0, but I'm not going to. I'm going to pull down the equal sign, and 15 minus 5 is 10. I'm almost there. I'm going to get rid of, let's see, so I subtracted to get x, to get rid of terms on the side that x is on. Now I'm going to multiply or divide. So let's look. 10 is being multiplied by x. To get rid of it, I do the opposite. So I'm going to divide both sides by 10. 10 over 10 is 1. I could write 1x, but that's the same thing as writing just plain old x. Now here's the problem. 10 over 10 is 1, but this time I have to write it. Do you see the difference? I could write 1x equals 1, but then I have to divide both sides by 1. It's just easier when you have 1x to write x, but when you have the answer being 1 on the right side, you've got to write that. All right, hopefully that made sense. Okay, and with number 6, we're looking at distribute first. Can we distribute? Absolutely we can. So let's go ahead and do it. I'm going to ignore the 7x. In fact, I'm going to pull the 7x down to remind myself, don't do anything with that 7x. So here we go. I'm going to distribute. 3 times 5 is 15. 3 times a negative x is negative 3x. And then I'm just going to bring down everything else. I'm going to bring down the minus 4x, bring down the equal, bring down the 11. So we distributed. That was our first step. Our second step, combine like terms on the same side of the equal sign. Do we have like terms? Yes, we do. So let's go ahead and start combining them. I see a 7x, I see a negative 3x, and a negative 4x. So basically, in your calculator, you could do a couple different ways. You could put 7 plus negative 3 plus negative 4, right? Or you could just put 7 minus 3 minus 4. And what do you get? When you put in that calculator, you get 0. So I could write 0x. But you know what? If I have 0 cookies, you don't see anything. So if I have 0x, we don't see anything. We don't write anything. So the x's are gone. And all I can bring down on the left side is a 15. I bring down the equal sign, and I bring down the 11. Wow, where'd our x's go? When our x's disappear, like in a problem like this, and we end up with a statement, like this statement is 15 equals 11, we have to ask ourselves, is this a true statement? Is 15 equal to 11? No. So when we say no, that reminds us, oh, that's right. There's no solution. No x in the world is ever going to make 15 equal to 11. So that's no solution. So we actually stopped after the first 2 steps. We didn't even have to do the last 3 steps on this one. Okay, moving forward. Yes, we can distribute. So let's go ahead and distribute. So 5 times 8 is 40. 5 times negative 3x is negative 15x. And that's all I can do. I just do one step at a time. So I distributed. Now I'm going to bring down everything else. And I'm going to move on to my next step. Combine like terms on the same side of the equal sign. I see like terms. I see a negative 15x plus 10x. So in my calculator, I'm going to put negative 15 plus 10. So let's bring down the 40. Negative 15 plus 10 is negative 5. Don't forget the x. Then I'm going to bring down my equal and bring down my 25. So I went ahead and I combined like terms. Get all the x's on the same side. Still only have x on one side, so we haven't been able to do that step yet, have we? Add or subtract to get rid of terms on the same side that x is on. This is very important. Sometimes people want to move this 25. Why? Always look at the side that x is on and get rid of things on that side. So I'm going to look at this 40, and I need to get rid of him first. He's just a positive 40. If you look to the left of him, there's no negative sign. That minus sign you see, that's a negative sign that belongs to the 5x. So this 40 is positive, and to get rid of it, we are going to subtract it. And whatever we do to one side, we have to do the other. 40 minus 40, gone. I'm going to bring down the negative 5x. Don't leave your sign behind. A lot of people will forget, and on this line, they'll just write 5x instead of negative 5x. Don't be that person. And then 25 minus 40 is going to give me a negative 15. And then, so we subtracted to help get rid of terms on the x side. And then we go ahead and do the last step. In this case, the -5 and the x are being multiplied together. See how the -5 and x are right next to each other with nothing in between. You don't see a plus, you don't see a minus, you certainly don't see a division sign. When two terms are like that close together, that means multiplication. So we're going to undo it by doing the opposite, which is to divide. And whatever we do on one side, we have to do on the other side to keep it equal. So -5 divided by -5, that is 1. I could write 1x, but I just write x. -15 divided by -5, that is 3. And that is our answer. All right. Can we distribute? Nope. There are no parentheses, so I can't distribute. Can we combine like terms on the same side of the equal sign? We sure can. On the left side, I see a 7x. I see a -4x. 7x minus 4x is 3x. So I'm going to write that. Plus 8 equals, and then just rewriting 44 plus x. All right, so we combine like terms. Get all the x's on the same side. Yay, we finally can do this. Let's move this x right here over to the left side. So to get rid of it, anytime we want to move something, we've got to do the opposite. So since we have plus x, to move it, we're going to do minus x. And we're going to do it to both sides like that. So then we have 3x minus an x. Don't forget, the minus x is like a minus -1x, or minus 1x. So 3 cookies minus another cookie, that is going to be 2 cookies. 3 x's minus an x is 2x. I bring down everything else. And then don't forget, we subtracted x on purpose because x minus x, gone. We're not going to write it. So once we're done with that, we go ahead, we got the x's on the same side. All right, we're looking at the 8. We're looking at you 8. We're going to get rid of you by doing the opposite, which is subtraction. So we subtracted, and that goes away. So we end up with 2x. Bring down the equal, and 44 minus 8 is 36, which brings us to our very last step. We're going to divide both sides by 2, and we get x equals 18. So I want to stop at this problem and talk about something. A lot of times when people see that we have a 7x and a minus 4x on both sides, they want to bring them together. They know they should, but they find themselves doing this, adding 4x to both of them, as if they're jumping over an equal sign. We can't do that. If you did this problem and got 7x plus 4x equals 11x, you know that you did it wrong. So let's undo what I just did. Okay, so when you see two terms that you can combine on the same side of the equal sign, see they're both on the left side, you just go ahead and do what they say to do. 7 minus 4, put it in your calculator, and you get a 3. The only time you're going to do the opposite is if you're trying to get rid of something and move it to the other side. So like when we subtracted our 8, we were just getting rid of it, so we had to do the opposite when we're getting rid of. We wanted to move our x to the other side, so we subtracted it to move it to the other side. But when you're talking about like terms on the same side of the equal sign, you just combine them. There's no doing the opposite. So please remember that. All right, yay, we're back to distributing. So we can distribute. 8 times x is 8x. 8 times 2 is 16. We only do one step at a time, so we bring everybody else down. Okay, next step, combine like terms on the same side. I see an 8x, I see an x. Once again, I'm combining them because they're on the same side of the equal sign. So 8x plus another x, that's 9 x's. And I'm going to rewrite everything. All right. Yeah, you noticed that too, huh? 9x plus 16 equals 9x plus 16. It's looking pretty suspicious. Let's go ahead and do one last step, get all the x's on the same side. Let's go ahead and move this 9x over. But when we do it, we kind of knew this was going to happen. It's gone on both sides. So when our x disappears and we end up with a statement, we have to ask ourselves, is this true? Does 16 equal 16? And we would answer, yes, it's true. So we would write infinite solutions. And the reason why is that this equation is set up so that you can plug any x in that you want, and it will always end up with 16 equals 16. So that's why there's infinite solution for x. No matter what x you plug in, you're going to end up with 16 equals 16, which is correct. All right, so if you notice, we've been using the DCGAM, the distribute, combine, get all the x's, add or subtract, multiply or divide. We've been using that for every single problem. And I think it's very helpful for students. You need to make sure that you've memorized the 5 steps. I use the acronym DCGAM because you can remember it, but practice really does help with that. All right, with this problem, we are going to distribute, but here's the thing. We're not distributing this 6x. It's not what's right next to the parenthesis. This minus is right next to the parenthesis. So what I'm going to do is I'm going to bring down my 6x, and some students like to change this minus into a minus 1 and distribute a negative 1. I think it's also just fine if you distribute a negative. If you say to yourself, what's a negative times a 2x? It's just a negative 2x. A negative times a negative 4, it's a positive 4. Now, if you didn't like that, feel free. We can do it again. We'll do it in green. We can change this minus into a minus 1. So negative 1 times 2x still is negative 2x. Negative 1 times negative 4 still is a positive 4. So either way you do it, you're going to get the right answer. And then after we distribute, we're going to bring down the equal, bring down the 40, bring down the 5x, and we're going to move on to combining like terms on the same side of the equal sign. I see a 6x, I see a minus 2x. Those are like terms. 6x, take away 2 x's, leaves us with 4 x's. Only going to do one step at a time, so I'm going to rewrite the rest of the problem. Let's see, get all the x's on the same side. Yep, we need to do that. So we're going to take this negative 5x and we're going to move it to the left. Anytime we want to move something to the other side of the equal sign, we've got to do the opposite. So we're going to add 5x. So 4x plus 5x is 9x. That really doesn't look like a 9, does it? There you go. We're going to bring down everything else, bring down the equal, bring down the 40, and of course, negative 5x plus 5x is 0. We're not going to write 0. It's just gone. All right, that leaves us with a 2-step equation. The next step, we're going to subtract the 4 from both sides. So we have 9x equals 36. And our very last step is to divide both sides by 9, and we get x equals 4. If you have the stamina, or if you can build up the endurance to do these types of problems over and over again, you'll find that it's a nice feeling because there are no surprises. Once you really take your time and work through these problems and practice, you're going to become so proficient that you're never going to be surprised. Well, at least not for this test. All right, so here we go. Distribute. We can distribute. 9 times x is 9x. 9 times 2 is 18. We only do one step at a time, so we're going to bring everything else down. The next step, combine like terms. Ooh, this time I get an 18 and a 2 that are my like terms. So I bring down the 9x. 18 plus 2 is 20. Just combine them. Only one step at a time, so I'm rewriting. Get the x's on the same side. I see that I have a positive x here. That negative sign belongs to the 4. So if I want to get rid of a positive x, I subtract the x from both sides to move it. So 9x minus an x, that gives me 8 x's. I'm going to rewrite everything else. X minus x, gone. I'm going to bring down the negative 4. And I move on to add or subtract to get rid of terms on the side that x is on. I'm looking at the left side, so I can get x by itself. I'm going to get rid of the 20 by doing the opposite. I'm subtracting. Whenever I do to one side, I better do to the other. Negative 4 minus 20 is negative 24, which brings us to the last step, and that is to get rid of the 8. I'm dividing both sides by 8, and I get x equals negative 3. I like it when we can use all the steps. This was very, very satisfying. Okay, let's move on to proportions. Proportions are when we have a ratio set equal to another ratio, or a fraction set equal to another fraction. And the easiest way to solve these is what we call cross multiplying. A times 2 is the same thing as 2 times a, which is 2a. We bring down the equal sign. 4 times 7 is 28. And then to solve for a, so note, There's no, in DC-GAM, there's no cross multiplying, but as soon as we see that we have a proportion, that's the first thing we do. So this is the one exception to the rule of DC-GAM. When you see that you have a proportion, your first step is cross multiply. And then you can follow DC-GAM. All right, so we can't distribute. No. Our last thing is to divide both sides by 2 and say A equals 14. Okay, once again, we see that we have a proportion. X has company. See how X is not by itself like it was last time? It has company. Whenever X has company, we're going to put parentheses around there to remind us that we are distributing to both when we cross multiply. So I'm cross multiplying, so 1 times X is 1X, but I'm just going to write an X. 1 times 2 is 2. And then the other side, 4 times 5 is 20. So I cross multiplied, and now I'm skipping all the way down to number 4. I'm going to subtract 2 from both sides and get X equals 18. Didn't have to do that last one. So we cross multiplied, and then we subtracted on both sides. That's all we did. This one, same thing. I see that X has company, so I put the parentheses around it. When I cross multiply, you can do either side first. I see right here that I want to put my more detailed side maybe first. It doesn't really, well, I'm going to end up with, that's okay. Let's just do it this way. 7 times X is 7X. 7 times -1 is -7. Note that I distributed to both the X and to the -1. I put the equal sign. 4 times 2X is 8X. All right, I'm glad I did it this way because it kind of makes us talk about something. We did the cross multiplying. There's no distributing when we already did it. There's no like terms. Okay, X is on the same side. If I move my 8X over to the other side, I'm going to have nothing left over here, and that freaks students out sometimes. So what we're going to do, instead of moving the 8X over to the left side, we're going to take the 7X and move it to the right side. We can do it. So if we're going to move it, we're going to do the opposite. This is a positive 7X, and the opposite's a minus. So we're going to subtract 7X from both sides. 7X minus 7X, gone. We bring down the -7, we bring down the equal, and 8X minus 7X is X. And we're done. Now I could have written 1X and divided both sides by 1, but I still would have gotten X equals -7. I would have got the same answer if I cross multiplied and did 4 times 2X first as well. All right, let's move on. All right, DC-GAM, we want you to move, oops. All right, making a mess on the board. All right, let's move down DC-GAM. Here we go, once again, X has company here and here. Let's cross multiply, doesn't matter which side you do. I just started with this one. 8 times X is 8X. 8 times -1 is -8. 2 times X is 2X. 2 times 2 is 4. No, we are distributing. We are cross multiplying and distributing at the same time. Okay, so no like terms. Yep, we need to get X on the same side. So let's go ahead and subtract 2X on both sides. We'll end up with 6X. We bring everything else down. That's gone. We need to do the next step. Let's add 8 to both sides. It's gone. 6X equals 12. And the very last step is to divide both sides by 6. So we get X equals 2. Okay, moving on. We've got a triangle with the sides of X, 3X, and 4X minus 8. Now, you know why I put them all together like that? Basically, perimeter means to add up your sides, and I did. That's one side, that's another side, and that's the third side. And when you add them all up, it says that it has a perimeter of 24, so we're going to set it equal to 24. Then we're going to go ahead. We are going to remember DC-GAM. We can't distribute. We can combine like terms. So here I've got 3X plus 4X. So let's see, 3X plus 4X's. That makes 7X's altogether. I'm sorry. Let's undo that. I think I'm getting hungry. It's about my lunchtime. So let's see. How about X and 3x and 4x are all like terms. So we've got an x, we've got 3 more x's, and then 4 more x's. Altogether, we have 8 x's. So let's see, we combined. We don't need to do this. And now let's go ahead and add 8 to both sides. So we're doing this step. We'll have 8x equals 32. And then very last step, divide both sides by 8. So that means x equals 4. Okay. All right, Michael's selling snacks to pay for a new video game. Each snack sells for $1.25. He paid $32 for all of the supplies. How many snacks does he need to sell to make a profit of $75? So let's talk about what profit means. Profit means when all is said and done, Michael will have $75 in his wallet that he did not have in the beginning. So that's his goal. And the way I've been teaching it is, let's put the goal on the right side. You want to make $75. So on the right side is the amount of money you want to make, and on the left side is the way you're going to make it. I don't know if that helps at all. It's got a lot of the same words, but the way you're going to make it goes on the left side, and the amount of money that you want to make is on the right side. All right, so let's see if this helps. We know he wants to make $75, but wait a minute. He already paid $32 for all of his supplies. So not only does he need to make a profit of $75, but he needs to reimburse himself that $32 that he went out and sold or bought supplies for, right? If he wants to end up with $75 in his wallet that he didn't have before, then he has to pay back himself that $32. Okay, how's he going to make this money? Well, he's going to sell snacks for $1.25 a piece. Do we know how many snacks he's selling? We have no idea. So that's where our X is, but we know each snack is going to be sold for $1.25. So on the left side, he's going to make his money by selling snacks for $1.25, and on the right side, we know that he's got to, let's go ahead and add these up together. Let's see, that's going to be a 7. He's got to make, after selling, or when he's selling these snacks, he has to make $107 in order to make a profit of $75. So the only step that we have left is we have $1.25, 1.25 times x. So to solve for x, we have to do the opposite. And I'm going to pick up my calculator in a second. So let's do the 107 divided by 1.25. Yeah, it would help if I turn my calculator on. 107 divided by 1.25. All right, 85.6. All right, do not put a box around 85.6 because that's not quite right. That means, imagine Michael selling these. He has sold 85 snacks, and he's like, oh, I only need to sell 0.6 more, and I've made it. What's he going to do? Take scissors out and cut the snack up and say, okay, here's a 0.6. Pay me for a 0.6. No, he can't do that. So really, he has to, this 0.6 tells us he has to sell more than 85, which means he's got to sell $86. Yeah, he might make a few extra cents after selling 86 instead of 85, but he needs those extra cents. So 86, that's the answer to that. Here we go. Michael now heads to the store to get his video and discovers that it only costs 59 cents. $59. As he heads to the checkout counter, he sees his favorite candy bar displayed and decides to buy as many of those candy bars as he can with the remainders of his money. How many candy bars can he buy if they are $1.25 each? Okay, how much money does he have? Let's put how much money he has on the right side. So I'm always basically putting something that we want to total on the right side. Well, we know he made, let's see, on the last problem, he made a profit of $75. Okay, so that's where we're going to start. He made a profit of $75. Okay, so that's what he has to spend. Let's see how he's going to spend it. We're going to put it on the left side. Well, we know he's going to buy his video game, so he's going to spend $59 for the video game, right? And he's going to see how many candy bars he can buy, and we know they're $1.25 each. Do we know how many he's going to buy? No, we don't. That's going to be our X. We don't know how many candy bars he's going to buy, but we know that each one of them costs $1.25. So let's see, money, how I'm going to spend, how spend, and money to spend. All right, once again, I'm not sure if that's helping anybody, but it's been helping a few of my students. So here we go. We've got the problem set up. The first thing we need to do is subtract 59 from both sides. So let's see, we're going to bring down the $1.25. We're going to say 15 minus 9 is 6, and 6 minus 5 is 1. So he's got $16 left after buying the video game. Of course, we're not counting tax. And so let's find out how many candy bars he can buy with $16. So we're going to pick up our calculators. This time mine's on, which is always great. And we're going to put 16 divided by 1.25, and that gives us 12.8. Now, can you imagine Michael going up to the checkout counter and having 12.8 candy bars to check out with? What did he do? Just take that, after the 12th, he took the 13th one and took out those scissors and cut it up, because he could say, right, hey, I'm going to buy this 0.8 candy bar. I have enough money for it. Okay, doesn't work like that. So that means he doesn't have quite enough for 13 candy bars. He can only buy 12. And so you'll notice that when we're spending money, we always have to round down. And when we're making money, we round up. That's the difference between these two problems. All right, I think that's it. You guys did great. Please remember that the more you can practice, the better. All right, see you in class.